Okay, I'm waiting for the connection. So you will later see a video, right, record on the YouTube, and which can easily access later, right? Okay. All right. So let's continue. Now this is one page which I call a GeoGebra book. Okay, because this is the name they use it for the collections of material. So each page, if you click on it, right, you will find that each page is what they call an activity. Okay, so this is an activity page contains an applet made with GeoGebra and maybe together with some other tags or question or even video. Okay, so you click on another page, then you will see another activity. Okay, so I have already put together several activities in this collection, which is called a GeoGebra book. Okay, to give them demonstration or some ideas of what can be included. All right. Now, similarly, if you have an account of GeoGebra, you can easily bookmark any of these materials you like. Okay, and then according to your needs, you may put it into some kind of book or collection, and then easily use it or organize it in any way you like. Of course, later on, if you would like to create some materials on your own, then you can also consider making some of the materials, or even copy my material and adapt it. For example, in this page, as an activity, you can find options of copy this activity. All right, then you will have a copy of your own under your account. And if you know how to edit it, right, then you can make changes to it. All right, and then try to make it your own materials and or use it in some other ways. Okay, is it okay? Right. Now, if you have any question, you can freely ask me. All right. I may decide whether I can answer you quickly, or maybe I leave it later if I think that is a bit longer questions and answers. All right. So so let me continue now. And so you can see that this is one example of an activity. It looks like that we can do some graphing, okay? And maybe I can demonstrate quickly here. Now, this is what I call a GeoGebra applet, okay? Where you can have a kind of quadratic graph, okay, shown here, and even together with the equation, all right? So I use some way to, to review the equations according to these 3 points, all right, that create the parabola, all right? And so I make an example like this so that the teacher may find it easy to generate different examples to discuss with the students. Now, by the way, I'm assuming that some of you may still have to do online lesson Zoom, or just like what I'm doing here. Right? So that can be one way that you can use it in your online lesson. Right? Or if you are doing it inside the classroom, then it can be projected on the screen, okay, and then discuss this example with the student. You see my point here? Later on, I don't know when you go to the school to practice, or maybe when you're working in school, or how far you may do it inside the classroom, or maybe you will do it in some online lesson, okay? Either way will still be possible now, okay? So you have to bear in mind that you may use it in either of this manner. Now, if you're using it in Zoom, then it will be similar to what I'm going to show you now, okay? So I can show you an example of parabola, and I can also show you the equation, or maybe I can hide the equations, okay? Or even hide the discriminant, and then test the knowledge about it, right? For example, I can ask you, what do you think about the discriminant of this parabola? Okay, then you can put in the chat area to tell me the discriminant is positive or negative, or in the classroom, then you can ask the student to demonstrate quickly, all right, whether they know it's positive or negative. Now you can now show the answers, okay, to let them know, right? Or maybe you can also ask them to guess what is the line of symmetry. Any guess here? Can you make a guess? What's the line of symmetry? Where's the line of symmetry for this example? Any suggestions? So you can put in the chat area if you had a guess, okay? Or you can use now if you're working in Zoom, then you can ask the student to use annotation, okay? To use a pen to draw on the screen, okay? Maybe you can ask them to mark somewhere on the x-axis. Where do you think is approximately the line of symmetry? Someone say x equals 3.x, okay? And it's good guess, all right, perhaps, all right, yes, very good. Someone is now trying it on the Zoom, right? Using a line or try to make a mark here. Maybe you can go to the x-axis right, to indicate roughly where do you think is the line of symmetry, okay? And then anyone can try to draw it with the zoom annotation. Yes, very good. Very good try. Okay, then you can see. Now, this is something that you can ask the student to do in the Zoom lesson, actually. Okay, you can ask them to draw it. Maybe you can give them 3 seconds, right, to think about it, and ask everyone to draw at the same time. Then you will see maybe a few lines marking here, right, or to tell you where the thing is the line of symmetry. Now you can see the graph. Here is the general form, and here is the standard form, right? Someone called it. Okay. So you can see very close, right? 3.8. All right. So you can see that this can be very instant examples to demonstrate or to discuss with the student inside the classroom. All right. You understand my point here? All right. So if we have time today, later on, I can show you quickly how I can draw this graph. Okay. Usually the student or the teacher can input equations of parabolas, right, like this. Okay, this is some common way to do it. Okay, but the way I now show you is a little bit different. I use 3 points to flexibly change the graph. Okay, so that is quite another way of drawing the graph. Okay, now, and so first of all, each of these activity can be used in this way. That means it may be some kind of online lesson, so that you will work with the student together, right, on graph, or maybe you show them. Let me see. Okay, maybe you show them these examples and then ask your question and let them try to respond to you in some way. But another very special way of using the GeoGebra here in this environment is to turn it into a kind of classroom activities. Okay, now you can see a button on each page of this activity called Create Lesson. Can you see this one? Okay, so if I click on this one, then the page can be turned into a kind of activity to share with the student instantly. Okay, so now I'm trying this part with you so that everyone can take parts together. So if I choose to, let's say, okay, maybe you can stop your annotation right here. All right. Right. So if I choose this create lesson, then there's a choice. Either you create the whole book, okay? You turn the whole book into a classroom activity, or you just turn this page, okay? That means this activity into a classroom task, okay? So I now choose the second one. Can you follow me? All right. Then I can now create. All right. So particularly, if you save the material under your account, then you can use it in the classroom in this way. Okay. Now it is turned into a GeoGebra classroom activity, and you can see a code here. So if you follow this link, that means if I copy it, I can put it in the chat area. All right. And when you come to this page, then you can use this code, right, to enter the classroom activity that I just opened. Okay. Could you please try it now? Okay. I can also just copy this directly. Okay. This is the website. Okay. So that means if you go to this page, then you can use this code, or maybe you can just copy the link with the code. Okay. Just like what you are doing here. And you can see now people are joining in. All right. Can you see the students are now coming in? So each block here represents one student's page. Okay. And I can also hide the names. So this is the part I can hide the name. So you won't see the actual student's name. Okay. That will also be very convenient, right, for your classroom activity. Actually, when I say classroom activity, you can also just give the links to your student before the lesson, okay? So that you can ask them to maybe try out the task before you go to the lesson, right? It doesn't mean that you have to do it only within the lesson. Is it okay? Right. Once you have the link, then you can send the link to the student anytime you like. Particularly, I encourage teachers to do some kind of pre-lesson task or post-lesson task, all right? That will also be very useful. Now, what does it mean? Okay, if you come to the individual page, now this is the teachers, right? The teachers will. If I click on one page, then you see this is one of the students, student one, okay? Student one is now here. maybe that student haven't made changes in the graphs, right? But I can invite any one of you just now try to turn or change the 3 points to give another examples of the quadratic graph, right? Then everyone, now you can see briefly, this graph is not the same as this graph. And you can easily see some students are now making changes of the graph. You see it on the screen? Okay. So you can see some students now are adjusting the graph. So go back to my activity. Here's my activity, all right? I can ask questions like this, all right? Now, maybe I can ask you to give me an example. Each student try to give me an example. Give me a graph that touched the x-axis and has a positive y-intercept, all right? So can you all do it? Can you try to make a graph which touch the x-axis and have a positive y-intercept? Can you do it now? Now I see that this graph is touching the x-axis and a positive y-axis, right? Y-intercept. This one is also, yes, correct, all right? So you can see which student can do it, right? Or which student may have difficulty, right? Do you know what I mean? Or you may also ask a student, the whole class to look at it. Which graph is not, all right, belonging to the type I mentioned, right? Maybe you can ask a student to justify or to let you know, because they can also see the screen perhaps, okay? Then you can ask the student to make a quick suggestions. Now, if I pause the activity now, then everyone cannot do anything now, okay? And then I can just look at the screen and then ask, okay, most of you can do it, right? Except maybe a few of you, can you find out which student I cannot do this, right? Or not yet, right? We may not say that, we should not say that they cannot do it, right? But they have not yet done it, okay? So which one, right? Can you tell? Can you identify which student? Not touching the x-axis yet, okay? So you can see it on my screen, am I right? Okay, so you can now see this student 10 or maybe student 1 and so on. Right? So you can discuss with the student in this way. You know what I mean? Okay, you can actually go inside and let's say this student 2. Now then I'm looking at the particular examples of student 2. Do you follow me? Okay, and now I can go into investigation. Do you think this graph is really touching the x-axis? So okay, actually now you can go inside the graph, and then I'm now using my mouse to zoom in. Can you see that? All right. So now actually I can still make changes, right? That means I can help that student to adjust it. Perhaps I can try to make it closer, even though I cannot make it 0. All right. Do you see my point here? All right. But anyway, this is still a kind of interaction with the student. And I'm even controlling directly that student's page, right? Or his or her own example, right? Even though the actual page is not really changed, okay? I'm just changing the result on the screen only instantly. Understand my point here? Okay. However, this can be useful for discussion, right? So maybe you can ask the student, can we make it closer to the x-axis? Right, so that it is closer to 0, the discriminant, right? So you can talk about it and then at the same time manipulate the graph, right? Control the graph in the way you like, okay? Is it clear to you? Now, don't worry, if I come back to the page again, it is the same original result, okay? It's not the one I have made changes, okay? And now I can resume it. So now you can go back to the page and then do your own adjustment, right? Any question do you have? So if I go to the page, now this is the original page, all right? I suggest some other question, or you can actually consider some other question that you can think of, right, in this environment, right? My main point is invite the student to make the examples, okay? To test how much they know or to let them show you what they know or what they can do, right? Or maybe ask them to create some interesting example and discuss with all together, okay? Is it okay? And don't forget that these can also be turned on and off, right? If you want to show it or not. And if you are controlling it as a teacher, then you can discuss with the students, all right? And what do they know about these values, or maybe, let's say, the discriminant, or maybe the standard form, or even the minimum point, okay? just like the previous question I asked you, I can also ask you to estimate the minimum point in this graph, right? To see how close they can get it. Right? Can you see this? All right. Or make use of the first equation to calculate or compute the minimum point. That's also something that you can ask the student to do. Okay. So any questions about this? Before we move on, maybe we can try another example. Any questions about these this layout or this setup? Okay. Now all these materials will be maintained here, right? Even when you leave this page, right? Or maybe even you log out, right? Because you can come in with an account, okay, and then you can log out and then leave, or maybe without account you can still access this page. But the material will be stayed here, right? So once you click the pause button, then you can revisit the answers of the students later, right? And then choose to discuss with them in a late stage, or maybe find out something that you want to further analyze, right? Based on this material. Okay. All right. Okay, then maybe I try another one, right? To give you a little bit more examples. Now, if you click on this, maybe I go back to the first page, right? So this is the first page. You can see the index, all right? And then you click on the chapters. This for this book, I put it into 2 chapters, right? The first chapter is about the problems, right? So these are the problems that I can demonstrate to you today, okay? And the second page, hi, hello, do you want to ask a question?
Hello,
Yes.
I'm the student 10. I don't understand why it is not the same as others.
Same as others what?
What? I don't understand why my graph so.
Okay, so you want to go back to your graph? Are you?
My graph not correct because I have touched the x-axis as the 2 roots. So two crossing 2 points. X-axis. Is that? Does it mean like touching? Does it mean I have?
So yes, you're right. If when I say the graph touch the x-axis, that means they will only intersect the x-axis at 1 point. Okay. If you cross the x-axis at 2 points, then usually we just got this is a general case. We say that this is crossing or cutting the x-axis. Okay. So and yes, you can see that most of the cases this is what we call touching. Okay. So that you can see that, for example, this is even though it's not exactly 0, right? However, I think that the student is trying to make the graph meeting the x-axis at only 1 point, right? So this is what we call touching, okay? The x-axis, right? Now, don't worry if some of you are not familiar with the mathematical content, right? It doesn't matter. Maybe you can also discuss with your classmate later, maybe find out more about this content, okay? And I know that some of you may be more experienced, or some of you may need more time to refresh yourself. This is still fine, all right? So this is not the main point about directly answering the question, right? But try to feel. Yes, Alice, would you like to continue? Sorry, I cannot hear very clearly because. Or how about you write the question in the chat, because I find that it's not easy to hear. Maybe the connection is not so good. All right, right. Don't worry. You can put your question in the chat area, right, to let me know later. All right. Thank you. Thank you for raising a question. So others can also try to ask question or discuss with me directly here. Is that okay? Now, maybe I move on. You can come back to this later if you want to talk about it again, all right? And don't worry, your examples are still there, right? I mean, all your work are still kept there, all right? It will not be erased, all right? Now, maybe the second one, I don't go through the details with you here, but you can see I tried different kind of questions, all right? In this set of material. So this one, I show you a picture, right, which is actually drawn with the GeoGebra at the beginning, but I take away the axis and then I just capture the image and then share the image here and then invite you to draw the same graph or something like this. Okay, that means you may try to make a graph similar to this one, And then you can directly input the equation. For example, you can write down y equal to x squared minus 4. Sorry, you have to, yeah. Okay, so you can do that. Then you have one graph, and then you can continue maybe to draw some others to see whether you can generate a pictures like this. Now, of course, you can be more creative and try different kind of picture. And usually, I would like the student to experiment in this way. Okay, try to see how they adjust or change the graph, and then try to see the result instantly on the page. And then you can also turn it into an activity. All right, and just like the previous one, and then let them show you what they can do. Right, and the second part is more challenging because I include a parameter k here, so that if you change the value, okay, the graph will also change. Now, what does it mean? I already showed you a slider here, right? So this is a slider. If you explore the tool in the GeoGebra, then you can see there's a slider option, right? You can create a slider and change the value of the slider here, okay? And that means you can now include the value k in the equations, right? So it can be x squared. Now, if I enter the exponent, then I will use the symbol over the number 6 in the keyboard, okay? Which is sometimes we call it a cap, okay? So x cap 2, then you will get x squared. Now, if I take x squared minus k, okay, I can use k anywhere in the equation, okay? And then you will have one graph that depends on k, right? So you can try it out like this. See whether you can make a picture, okay, similar to what I've done here. So this is another kind of activity that invite the student to create a graph and based on some parameter, and then try to develop the understanding of the graph and the transformation, just like what Ramya shared briefly at the beginning. Okay. Now, so if I turn it into activity, then I can click the create button, create lesson button here. Okay. And so similarly, I can choose to turn this activity instead of the whole book. All right. And then I can create it. Now, if you want to come to my page, then you can do it directly in this page. This is another page. Okay. I put in the chat area. Now, I won't spend time here. Okay. So you can keep this and then show me or share with me your examples later. All right. Probably not within the sections now. All right. But if you want to have a try and then share with me your examples, then I will have a look and then discuss further with you in some other occasion. Okay. Or discuss with your classmate if you like. All right. Now, meanwhile, maybe I can have a look in the questions in the chat area. So let us say that when you say maximum point, does it limit to 1 point? Oh, yes, right? Because maximum or minimum, okay, refer to the vertex of the parabola, right? So that is only a single point, okay? And of course, I'm talking about parabola, okay? But if you're talking about cubic equations or other polynomial, then you will have more, you can have more than one maximum or minimum points. Can it, I see another question. Is it possible for us to put a domain for a function? Yes, it is possible, right? Let me see whether I know, but I may not quickly recall the syntax here. But the answer is definitely yes, okay? You can check the manual later if I cannot show you today, okay? Maybe I can have a try. Let's see, I have an fx here. Can I, let me see, I can use the function. Can you see the syntax here? Okay, I now using function, and then I can enter a name of an existing function, f, okay, or something that you create now, and then specify the start value and the end value. All right, can you see this? All right, so that means I can now say x squared, but I would like to have this from 1 to 4 only. Okay, so that is, oh, I see, this is the graph. This is the one. All right, can you see it? Okay, now, so if you want to check what you can do, maybe you can refer to the help menu, right, to find out more. I think you can, yeah, you can see the help and the feedback menu here, right? So that is the, yeah, that is the part that you can open the menu, all right? Okay, now I see some of you are trying, okay, but I won't wait for you here now, all right? So you can come back to this page later if you copy my link, all right? And then I better move on, right? Because I would like to quickly go through some other examples together with you. Is that okay? Now this one is called parabola and also with a triangle, okay? You can do it. This is a kind of problem to solve, all right? So I would like to check the area, the minimum, or sorry, the maximum area of this triangle, okay? And some of the answer may not be so obvious. And this can be a kind of investigation for a student. Yeah. Okay, so let's move on to see some other examples. And so this one, you can use the input box, right, to enter or to change the equation here. I give some example for students to explore, right, to see each pairs of equation and see how they are related. And later on, they may also create their own examples, all right? When doing so, then they may try to investigate how the graph, right, and how two equations of the graph can be compared, all right? Maybe you can think about it, how it can be turned into a lesson activity later, okay? And this one, how about this one? Maybe you can have a try so that we can also give some time, okay, to check whether you have any questions or not. So this one here, you can move the point B, okay, to change the line and then try to make this line the tangent to the parabola. Right? If you have that, you can do so, then you can change the parabola as well to consider another example, okay, on your own. Right now, I turn it into an activity again. Okay, you can see this page. And now I can show you the link. Okay, so you can come here to have a quick experiment, because this one is easier to manipulate, I think. All right, and then you can see the results together. And let me go through to, yes, Alice's earliest question in the chat as well. So we would have a graph open downwards. Oh, yes, you're right. If you, I think you're referring to the previous question, right? If you have a maximum, then the graph should be opening downwards, all right? So that is the way we describe it in English, all right? I think it's similar in Chinese, am I right? So you have similar description in Chinese or in another language, right? Which is very much the same. Yeah. Okay, very good. Now see, you can see some students coming. Let's have a quick check, okay? So that is one example. Yes, this is one line touching. Now this line is touching the parabola. And you can see the equation. Do you think that this is correct? Or you can make it even more accurate. Now you scroll, zoom in, then you can see that actually the line is cutting it. Do you notice that? Okay. Okay, you can, that means you can make it better, right? I think you can do it a little bit better and then try to check how the line can be a tangent to the graph, right? Actually, maybe I can show you, or maybe I can look at another example. Let's see, how about this one? This one looks like, okay, do you think it is touching? Interestingly, it is the same one in the other example, right? It's also not touching, okay? So who can do it? Can anyone tell me? I think this one is probably is correct. Can you see that? So it is a tangent, right? Quite likely. And you can check the equation here as well. Okay. So that is something for the student to follow up. All right. And that is a starting point, right, for them to explore, right, experiment, and then go on to verify, right, or to be more certain about whether it is a tangent. And you may need some other technique, right, to go through it. But at the same time, at the beginning, I think you would like them to have a try, right, to experience it, right, to get a sense of what does it mean to be a tangent, or even make a guess about the equation. Okay, can you follow me? Right. Now later on, you can also change the equation. Okay, if you click on the yellow box, then you can change the equation. For example, this one, I can turn it into 3. Right. Then maybe we'll do it again to see whether you can make it a tangent. Okay. Is it a tangent? No, not yet. but I think this one is. All right, can you see that? All right, so you can freely explore by changing this parabola and then quickly check how the line should be adjusted, right, to make it a tangent again. All right. All right, so this is something for you to further explore again. All right, and in this page, let me see, have I posed other questions? Yes. Okay, now let me explain it here a little bit. Now in this page, I have an applet, okay? But I also pose a question here below. Do you notice that? Okay. Now you may not have time to answer it, right? But in case you want to type something to see what happened, then you can have a try. Don't worry, just type anything you like, okay? And suppose this is a question for students to further show us, right, what they see or what they think can be the relations between the line and the parabola. And then in the activity page, right, here you can see the students. Do you notice that? All right, so these are different students, right? You can see 1 out of 2. What does it mean? That means there are 2 tasks inside the page for the student to complete. One is the graph, one is the question I asked, okay? And you can see, for example, student 10 is 2 out of 2, right? So that means the student have tried the graph and also answer something here. Can you see this? Okay, so that is something typed by the students, okay? And that is the students page, right? So I can see clearly which student had answered or tried both tasks, right? Or just one of them, okay? And you can see the blue bar here to indicate how far they have finished, okay, at this page. Understand? Now, if you look at, if you go to the left side, then you can see the breakdown of the task 1 and task 2. Task 1 is just the graphs, okay? Task 2 contains the question. And then I can see some of you have already entered something here, right? So task 2 is about the written answers, right, from the student, right? So you can encourage them to talk or write down their findings, their observations, their conjectures, all right? And this can be very useful for later discussion or follow-up questions. And particularly, it can be done before the lesson or after the lesson, right? So that you can have time to go through the written answers, right? And then to find out what kind of things can be further discussed with the whole class. Okay, very good. Some of you already written down very clearly, actually, all right? Very good, some relevant answers and also useful observation here. Can you see what's going on? If I click on this is one answers I provided by one of you, okay? So I can see some of you are trying to type your expressions here. Okay, is it clear to you so far? How it works, all right? Okay, so you can continue if you like, okay? And I think we still have time to go through 1 or 2 examples, all right? And now this one, come to this page, is something about geometry, all right? So you can drag the circle and you can change the radius, all right? Then see whether you can make this circle pass through all 3 points A, B, and C, all right? Or you can even type an equation. I give you different means to do it, all right? So you can drag it, control the slider, or even directly input the equation, all right? And then see whether you can make the circle by fitting all the 3 points, all right? So let's have a try again. Okay, don't worry if you don't have much time to do it, all right? Just have a little bit, okay, exploration here, all right? And then later on, when you have time later after the workshop, we can come back to every one of this and then go through it in details, perhaps, okay? And then share with me, right? Maybe some of the finding or questions. I mean, question as a student or question as a teacher, all right? So you may have different questions about how to use it inside the classroom. Then you can always come back to me, okay? Okay, maybe you can try a little bit, right? Let's do it in 1 or 2 minutes, see whether you can make a good circle, right? Passing through the 3 points and how well you can do it, perhaps. Okay. So you are seeing the circle. Is it easy to manipulate? Is it easy to drag and control, right? How do you feel about it?
User-friendly.
Okay, very good. Have you done something like this before, Samson?
No.
Okay, then go ahead, right? Just try how you feel, right? And later on, you may also discuss or share with the student, right? Invite them to try as well, right?
Also, so interactive. I have some like guided inquiry, but not this kind of so interactive.
Oh, I see. Well, you may consider, right, adapting it, right, or maybe transform it into something that can be done in this platform, perhaps, right? Or discuss with us later. Yes, Alice, you want to say something?
I wonder if the center is located at the intercept of the three angle divider line.
Oh, yes. So you may know something about the properties, right, of this what we call circumcircle, right? And then you can base on this, right, to try to actually, if you have the full tools in the GeoGebra, you can do some constructions, what we call geometric construction. For example, draw the perpendicular bisector, right, and then get the intersection of the perpendicular bisector. But do you notice that I also deliberately use the square grid to do it here? Assuming that some of you can also make a try and error and then make a good estimation, okay, based on the square grid, okay? Now, so I'm thinking of different ways of approaching or exploring this problem, right? On one hand, of course, you can base on the geometric theorems that you know about circles, triangles, okay, and then do the geometric construction. But you can also have a try using the square grid, okay? Can you make a good guess which grid point? Actually, in this example, I choose the point ABC in a special way, right? So that the center happens to be a grid point, right, on the square grid. Do you notice that? Mm-hmm. Can anyone have done it? Have anyone put D? I think this one should be quite close, all right? So you can see D here at this point. Just based on the position of the point D, can you see that it is equally far away from A, B, and C? All right? And the radius R is very close, although it may not be exactly the value, okay? And if you want, you can type R equals, now I'm changing the values of R in the input bar. I can directly type R equal to 1, then I change it, right? But actually, in this case, the R is equal to, do you know what's the values of R? Anyone know? What's the radius? If you're looking at this picture. 3.2 is the approximation.
Oh, no. Okay, approximately.
Yes, approximately.
Just
approximately, if you want to.
The square root of 10.
Sorry?
Square root of 10.
Square root of 10. Yes, you can type square root of 10 like this. Can you see what I'm typing? I can enter, all right? Then this is the radius, okay, based on square root of 10. Right? Of course, this is still an approximation, okay? But it's quite flexible. Do you see that? I can type and some more accurate values if I like. And you type in the box here, then you can also enter the equation. So it can be x to the power 5, x minus 5 squared and plus. Okay, this is what I call a cap. Okay, you see this symbol? It's a cap, right? To use it for exponent, right? And y minus 2 and then square. So that is the way we do it, right? In the form of an equation. Okay. So let's say if I put equals 9, then it's not really the 1. It's smaller.
Teacher, this bathroom is so much problem. Flushing. She has to go to shower, but Royce went before.
Okay, so
flush. Just saying yes, I'm not even
okay.
Her.
Yes, Vivian, do you have any question?
Royce to flush.
All right. So let me know if you have any question, right? Or you'll put in the chat area to share with us.
All the toilet is coming up.
Okay. Okay, so now feel free to share with us, maybe in the chat area, or use the mic if you want to talk to us. Okay. Maybe I'll leave you to explore further on this page later on. Any quick question before I move on about this example? So you can gradually see that I move away from functions, algebra, and then do something more about geometry, okay? Or even maybe analytic geometry, okay? Or what we call coordinate geometry, right? That is also quite a lot of things that you can try out in this environment with the students. Okay? Now maybe we can now do something about, yes, really about geometry itself, right? Maybe looking at angles. Right, I'm now turning to another page, okay? This is a rather typical question in the textbook, showing you some angle, but I give you only the label, all right? And although you can actually change it into values, that means angle measurements, or change the colors as well, all right? I give a quick demonstration below, you can follow it, right? Or I now do it here directly. For example, we want to change F, then you can use the style bar. This is a style bar, all right? And then you can make it red, okay? And now turn it into red color. And then you can also change the appearance, right? Whether you display the name is the letter F, but you can also display just the value, okay? So that is the value. That means if you move it, then you can see clearly the measurements of the angle. Can you see that? All right. Now I can do another one quickly. And then I can also show the value. So now this is a kind of template. That means depends on what question you want to ask the student. I'm now showing you, I just maybe choose two angles to talk to the student. Let's say if I now have these two angles, 81 degree and 125 degrees shown on the graph, which angle can you find? Now, if you're doing it on a Zoom, then you can ask them to just use the annotation tool to drag it, or maybe because I have the label, then you can type in the chat area to tell me which angle you think you can find, right? Based on these two measurements. Yes, very good. Some of you are now trying to show me in the chat area. Sorry, in the annotation. Okay. Can you see what I can do as a teacher with the student? Okay. Now, similarly, you can change to another angle and then go on to discuss or check with students quickly to see how much they are familiar with the angle measurements and the geometry or properties involved in these questions. All right. So that is quite flexible. At the same time, maybe I can also ask you, let's say, to demonstrate to us, okay? And if you want to, let's say, turn some of angle into measurements, right? And so that you can find all the other angles, what will you do? Now, once again, I can turn it into an activity, okay? Maybe I skip this part. Do you know what I mean? Okay. Then everyone can have the diagram and do it on their own way, because they may not be so familiar with everything, okay? But you can let them choose. That means they may, based on their understanding, based on what they know, then they can do some simpler questions first, or maybe choose some simpler cases to start with, right? And some of them may go on to demonstrate maybe better understanding or even more challenging questions, right? So that is some questions I put here already, okay, to suggest that you can work it out with the student. And even I have a multiple choice question here, right? Maybe you can have a try. Maybe I turn it into an activity so that you can now try the MC as well, right? The MC questions. Okay. So if you come to the page, maybe you quickly pick an answer in the MC question so that I can show you what the teachers can see, okay, immediately the results of the student. And I now can go back to Alex's question as well. Could you please elaborate how you find the radius of the circle? Okay. Yes, in the previous example, I can go back to it quickly, I think. Yeah. So if you choose the correct center, right, maybe not this page. Let's see, I choose this page, okay? So if this is the center, then you can find out the distance between C and D. Just look at the grid here, right? And if you look at this 3x1 triangle, maybe I can I draw it? No, I cannot draw it directly, but I can use the pen perhaps. can use the pen. Okay. Can you see this one? Okay. So based on this triangle, then you can see the DC, the length DC is root 10. Similarly, DB, you can also find another 3x1 triangle. Here, similarly, DA, okay, it's the same. Can you follow? That's why we know that this is square root 10. Right. So I hope that you see something interesting or in some of these questions. Okay, let's move on. Okay, how about this one? All right, now in this page, you can see that I have 3 tasks in this page. That's why you see 1 out of 3, okay? 1 out of 3, and then some of you have done a little bit more. Can you go to the multiple choice questions and just quickly pick an answer, no matter if it's right or wrong, okay? So that I can show you what it looks like. So, all right. So this is the angles page. Task 1, this is the task 1. Task 1 is the figure itself. Task 2, now task 2 is the multiple choice question. Yes, very good. Okay, so you can see 7 of you choose A, and then quite a lot choose C. Okay, only one choose D. It doesn't matter. It may be a wrong answer. Okay, but you can see the this is demonstrated. And can I show the, yes, I can choose to show the correct answer. Okay, this button, right? Because I already marked which answer is correct, right, in the setting here, right? And without showing it, then you can still ask the student, do you agree? Are you all sure that A, B, C are correct, for example, or are you sure A, C is correct, something like that, right? Before you show them the answer. Is it clear to you how it works? Okay. And then the task 3 is an open question. All right. I just ask you as a teacher, right, what question you can ask. Right. So you can go ahead and try it out if you want. Okay, thank you. So that is another example I can show you. Now, I think the other one, I won't have time to go through it, right, but I can give you quickly an idea. That is a cube, right? So this is a 3-dimensional cube. And you can also ask students to make a triangle. Okay. So I can ask them to maybe give a right angle triangle, which is not isosceles. Then you can, this is not the one, okay? But then you can ask them to draw some triangle and then share with each other. There will be a lot of examples that they can create here. So that can be another kind of freestyle questions that you can ask. Another one is a problem, right, to solve. We're going to find the angle DGE, okay? And you can have a try. And actually, you can also draw lines. You can also construct other lines if you like. Okay, there are a lot of things to do here. And the one below is for writing. Okay, so you can drag, you can use the pen, all these things. Okay, all these to highlight it or type directly. Okay, your answer. Okay. And that means you will give the student a chance to express the answers, right? Or even write down some kind of solutions, even though not too long, okay? And then give a record, and you can analyze and discuss with them later. Okay, then maybe for today, I can probably only demonstrate the activity, how we can use it to work with the students together. Perhaps next time I can show you how to create a file, all right? And then put it in the GeoGebra web, right? And maybe do it like this, like what I'm trying here, okay? I already suggest some of you to download, right, the software, actually, okay? So that is my suggestion. If you go to the app download page, then you can see GeoGebra Classic 5. Now, this is the one I'm still using, although actually this is the oldest one. Okay, if you see the other one, there's a newer ones. However, I find that the later one may not be so useful from my point of view, but it may be just my preference. Okay, so it's up to you. But don't forget that the layouts are quite different. Okay, and so that's why I start with Classic 5 and then give you examples if we have time. Then I can show you how I use the Classic 5 to create examples on my desktop and then upload it to the web page, which is quite simple actually. Okay, it involves quite just some friendly steps. Right, it's not too difficult. But maybe I do it next time. Okay, when maybe we can have a try to explore other examples that you can find on the web, and then go ahead with some of your own way of creating some simple file. And next, in some other sections, then I will maybe have more time to go through the process of generating the files, right, together with you. Is it okay? All right, so I think we can stop the